So we're going to do a little bit more of trig with algebra. And one of the big things of algebra that we learned in first semester was all the techniques of different kinds of factoring that we had. GCF factoring, star factoring, split factoring. Okay, so all those different kinds of factoring we're now going to do with trig. But one of the things you've got to know about before we can do trig factoring is, well, you know something's going to factor when it has a power in it. So let me just talk with you a little bit about how we write power in trig. Okay, what does it mean to square something? Okay, so x squared really means what times what? X times x. Okay, that's what squaring something. In trig, we write the power after the sign. That's just the format of where it goes. But it still means multiply it by itself. And so it would be sine x times sine x. That's what it means to square something, is to multiply it by it. So there actually are two x's and there are two signs. It's just the way that it's written is with the little 2 after the sign. Sometimes the people will write it this way, sine x, and they'll put parentheses, and then they'll put the square on the outside. That all means the same thing. It just means to multiply it by itself. There are 2 of them. So if you cube it, then you're multiplying it 3 times. All right, so that's one thing you need to know. The other thing is you just still need to have a working knowledge of the different kind of factoring things that we did first semester. So GCF means to pull out what they have in common. Okay, pull out the common factor. That is usually when you have only one plus or minus sign. Something plus something or something minus something. You have one of those. That's GCF. We did star. Star works when there are 3 terms. So you have 2 plus or minus signs in the problem. Something plus something plus something. There's 2 of them, which means there are 3 terms altogether. That's when you did star. And then the last one that we learned of factoring type was split. You have to have 4 terms in order for split to work, which means you need to have 3 plus or minus signs. Maybe I should add after star. I'm going to add that you need 3 terms, which means 2 plus or minus signs. Okay, I think that's better. If I put 3 terms, 2 plus or minus signs. So it kind of just grows. If you only have 2 terms, that's GCF. If you've got 3 terms, that's star. If you've got 4 terms, that's split. So we're going to see how those strategies that we learned back in the algebra days, how they relate to trig today. So I've got 4 or 5 examples. We'll see how many it takes us before we feel comfortable. All right, so the directions will say something like factor and solve. Okay, factor and solve. And so our first question is sine cubed of x minus sine of x equals 0. Now, one of the big rules about factoring is it's got to be equal to 0. Okay, that's primary. If you don't have it equal to 0, then you need to do some math on both sides to help it be equal to 0. Once you have it equal to 0, I know. Then you're going to count up how many terms there are, which will help give you a clue as to what you're going to do. There are 2 terms here. There's only 1 subtraction sign. And so this will be GCF. What is the greatest common factor? What's common between these 2 terms? Sine x. Right. One of them has 3 of them, and one of them has 1, but what they've got is common. So we're going to take the GCF And we'll take sine x out. And that leaves me with sine squared x, because I've taken one away, so the cube goes down. And then what's after the minus sign? Yes. And I set that equal to 0. So that is now what's called factored. After you factor, you take each piece and you set it equal to 0 by itself, so it becomes like two problems in one. So we're going to take sine x, which was the GCF, we'll set it equal to 0, and we're going to work on solving that. And we'll also take sine squared x minus 1, set that equal to 0, and you'll work on solving that. So now it looks like your homework from last night. We're just adding factoring as the first couple steps. So for the left side, we're going to apply inverse sine on both sides. So inverse sine applied to regular sine, and then inverse sine applied to 0. That's going to cancel out the inverse sine and the sine, giving me x by itself. And then what that is asking me for is the y-coordinate in a positive quadrant, because 0 is a positive number. So I want the y-coordinate in a positive quadrant. What pi is going to satisfy that? When do I have a y-coordinate that is equal to 0? It's only one place. 0, pi. Okay, got to have pi on your answer. With the other half of the problem, I'm going to add 1 to both sides. So plus 1 plus 1. Then that gives me sine squared x equals 1. Then what do I do to both sides? Square root, and what goes in front of every square root? Okay, so I'm going to now use the square root on both sides. So I'm going to have sine of x equals plus or minus 1. Now this becomes two more problems. So I need to do them separately. I need to first figure out what the sine of x equals 1. And I also need to figure out what the sine of x equals negative 1. So now this becomes additional problems. I'll use inverse sine again. So inverse sine around sine of x and inverse sine around 1. Cancel out to x is by itself. And I want the y-coordinate again in a positive quadrant. So it's a similar question, only this time the y-coordinate has to be 1 in a positive quadrant, and so that's going to happen at half pi. For the other one, I'll do the same thing. I'll apply inverse sine to both sides. So I'll have the inverse sine of negative 1. This is asking me for a y-coordinate, but it's asking it for me in a negative quadrant. And the only y-coordinate in a negative quadrant, that's negative 1, is negative 1/2 pi. So the three total answers for this were the 0 pi I got for the first part, and then 1/2 pi, and negative 1/2 pi. So I ended up with 3 answers instead of just 1 for this problem, which should make sense because what was the power of the problem I started with? 3. And when there's a cube power, then you're going to need at least 3 answers. Any questions on that one? That was a GCF one. Okay, yeah. Hey.
Just something pull that was to answer. So do we have to put like 1/2 pi and then negative pi, or can we put plus or minus?
Oh, sure. You could write plus or minus. Yeah. All right, another one. Okay, again, factor and solve. Let's do sine cubed again. This time plus sine x cos squared equals 0. Okay, so again, it's a cube, so I'm going to have at least 3 answers, if not more. But there's only 2 terms because there's only 1 addition. And so this is still considered a GCF problem. So what would I take out this time? Same thing, sine x. And so I'll take sine x out. What will be left for me is sine squared x plus cosine squared x. Is that equal to 0? So now I'll take each of those and set them independently from each other equal to 0. So the sine of x gets set equal to 0, and the sine squared plus cosine squared gets set equal to 0. Now I picked this one to show you because it has kind of a unique way of solving it that we didn't see in the previous problem. For this one, the left side, sine of x, is easily solved with an inverse. And so x would be the inverse sine of 0, which you actually had in the previous problem. So that would be a y-coordinate in a positive quadrant. So that would be 0 pi. The difference is you look at the second half, and if in the first half we used sine inverse, how do you decide which inverse to use in the second one? Because there's both a sine and a cosine. Do you use sine inverse or do you use cosine inverse? How do you know which one to use? So that's what I'm going to show you how to do so you can make a good decision. All right, so let's focus on this one. Actually, the first thing to do is not an inverse at all. It's to subtract cosine. So I'm going to subtract cos squared to both sides. That will give me sine squared left on one side and negative cosine squared on the other. Then, after I've subtracted cosine squared, I'm actually going to divide cosine squared. And when I do this, I get sine squared divided by cosine squared. Now we already know what regular sine divided by regular cosine is.
You don't divide by negative cosine?
Nope. Divide by positive cosine. All right. What is sine divided by cosine? Tangent. And so even with the squares don't cancel out. It is tangent squared. Now on the other side, what am I left with? Negative 1. Okay, so this is a very unique kind of question. When you have a combination of 2 trig problems in the same problem, you've got to move one and divide it so that you can get down to one kind of trig problem. All right, now what's next to do on both sides? Okay, square root. Oh, shoot. Oh, nuts. My fault. I just copied my notes wrong. This is a it's a subtraction problem. I'm so sorry. It doesn't change it a lot, except it just helps me fix this. So sorry. Minus, plus, plus. So it is a positive 1, not a negative 1. Okay. Now, we do a square root on both sides. That will get rid of the square, so I have tan x. It will give me plus or minus 1 on the other side. So now I was trying to decide, am I going to use sine inverse? Am I going to use cosine inverse? The answer is actually neither. You don't use sine inverse or cosine inverse. You use tan inverse. And so we'll use tan inverse. So x by itself is tan inverse of plus or minus 1. So this becomes 2 problems. It's tan inverse of positive 1, but it's also tan inverse of negative 1. And hopefully you've done tan enough to know, okay, I need a positive quadrant where tan is equal to positive 1. Who knows where that happens? It does happen at 1/4. And then on the flip side, I need a negative quadrant where tan would be equal to negative 1. And so I have negative 1/4 pi. All right, so my overall answers are x equals the original 0 pi from the beginning, and then plus or minus 1/4 pi. So Hayden, yeah, you could write it like that for your answer for that one. But there are 3 answers which match the cube that we had at the beginning. Okay. Here's a third one. And I know sometimes it's like, okay, we've already seen 2, I think we've got the hang of it, but each time I want to show you something different so that when you see it on your homework, you've at least seen it once before. So let's try this one. Square root 2 cotangent x sine x plus cotangent x equals 0. Okay, good thing it's equal to 0. Okay, again, I know that there are lots of cotangents and sines here, but this is still only considered 2 terms because there's 1 addition sign, so this is still a GCF opportunity. So there has to be something in common to pull out, and I notice that this has a cotangent both before the addition sign and after the addition sign. So cotangent will be what I pull out as my GCF. That leaves me with rad 2 sine x plus, now what am I left with after the addition sign? A 1 equals 0. Okay, so we're going to set each of them equal to 0 separately. So cotangent of x is set equal to 0, and rad 2 sine of x plus 1 is set equal to 0 as well. Okay, for the first one, the trig inverse I'm going to use is cotangent inverse. So x by itself would be cotangent inverse of 0. Now you're going to want to change cotangent inverse into its other 2 inverses. So cotangent inverse is cosine inverse over sine inverse. That's the rule for cotangent, cosine over sine. The 0 goes with the cosine in the numerator, which means a 1 goes with sine inverse in the denominator, because 0 is over 1. 0 is always, you always have 1 in the denominator. Which means to answer this, I need a positive x coordinate and a positive y coordinate, so I need to be in quadrant 1 with a combination of 0 and 1. So where does that happen? 1/2 pi. Okay, then I go over to the other one, solve that as well. We're going to subtract 1 from both sides. So rad 2 sine x equals -1. Divide both sides by rad 2. So sine x is -1 over rad 2. And the rad of 2 is something you do have to rationalize. This is one of the very few things in trig that you do need to rationalize. So we need to multiply by rad 2 in the top and bottom. That's going to give me negative rad 2 on the top over a whole number 2 on the bottom. So rationalizing just makes it easier for me to use the unit circle. So to get x alone, I'll use inverse sine around the negative rad 2 over 2. So I'll be looking for a y coordinate, but I'll be in a negative quadrant because of the negative rad 2 over 2. Very good. -1/4. Okay, that's in quadrant 4. All right, so my answers for this one, I had 2 of them. So x was 1/2 pi from the front part, and negative 1/4 pi from the second half. Okay, I think one more problem will seal the deal and we'll be good for our last one. I was going to do 5, but I think we can get away with just 4. All right, so last one. You can kind of probably expect what's coming up next because we've done 3 GCFs in a row. But we have not done a star or a split. Okay, 2 cos squared x minus cos x minus 1. All right, we recognize this as being star, or you should, because it's got 2 minus signs in it. So just a review of what we need for star. We need to know all the coefficients, so it's going to be helpful to you to put an extra, I put it in yellow, an extra 1 right there, because we do need all of those. So reviewing how star works, we look at the first term, which is 2, and the last term, which is negative 1. So that makes negative 2 for the top of our star. So the beginning, the first term and the last term combined. And then we look at the center term, which is negative 1, and that's the bottom of our star. And then we have to find 2 numbers that multiply to make negative 2, but add up at the same time to make negative 1. So that'll be 1 and negative 2. Now here's where some of you guys get sloppy. You just jump and say to the answers of 1 and negative 2 right here. You just look at those and you just like totally skip the rest of it. All right, what we need to do with the 1 and the negative 2 is remember how to properly use those. All right, so for star, we start the problem with 2 cos squared. Then we use the plus 1 from the numbers that we chose from our star, and we put cos on it because cosine was the term in the middle. And then we put minus 2 also from the star, and we put cos on that. And then we end with minus 1 equals 0. So now we have 4 terms instead of 3. We traded the 1 center term out for 2 center terms. And now we split factor. So star leads to a split factor problem. And you're going to take out what's in common on the front side, on the right side, the left side, excuse me, of the yellow line. And we notice that we can take a cosine x out as a GCF, leaving me with 2 cos x plus 1. So that was what was in common. What's in common on the back side of this split factor problem? Just a negative 1, that's it. But when I take the negative away, that leaves me with 2 cosine x plus 1. What is it important to check at this point? That they match, right? That the 2 parentheses are the same. If they're not, then you did something wrong in your star or something wrong in your split. But these 2 match. So I'm going to take the cosine and the minus 1, which were what I pulled out of each side, combine them together, cosine of x minus 1, and set it equal to 0. I'll also take what was in parentheses, 2 cos x plus 1, and set that equal to 0. So I'm setting each of the factors equal to 0. And now you're on the home stretch, ready to solve. We'll add 1 to both sides. And so cosine of x equals 1. So x by itself must be the inverse cosine of 1, which is the x coordinate in a positive quadrant. And so that is going to happen at 0 pi. And then for the other question, we're going to subtract 1 from both sides. That leaves me with 2 cos x equals negative 1. Divide by 2. So cos x is negative 1/2. and then use inverse cosine again. So x by itself is the inverse cosine of negative half. And so I need an x coordinate in a negative quadrant. All right, where is that going to happen? 1/6 would have given as a, okay, so it's a third, but it's not negative 1/3. Negative 1/3 is in quadrant 4, and cosine would still be positive in that quadrant. I need cosine to be negative, which puts me in quadrant 2. Okay, quadrant 2 is a negative quadrant as well, because it has negative numbers in it. And so this would be 2/3 pi. So our answers, x equals 0 pi from the first part of the star factor and 2/3 pi for the second part. So you can always tell what kind of factoring you should use based on how many terms there are in the problem. And then you're going to be coming up with definitely multiple answers, not just one, but 2 or 3 answers for each question.